Okay, so this is complex packet number 16, round one at least. So here we go. First thing I'm going to do is I'm going to turn this 68 degrees, 18 minutes into a decimal. That makes most sense for me. So 68 degrees plus 18 over 60 equals. Let's figure out what that is. You got that for me, Jordan? Jordan's my sidekick here. You can't see him, but he's Alright, so that should be 68.3 is what it is. So 68.3 degrees is that. That's good. Alright, we're going to write that up there so I don't forget it. 68.3 degrees. Okay, good. Alright, now, I'm going to break this into two different triangles here. Okay, so triangle 1 that we're going to solve first is going to be green triangle. Green triangle is going to go like this. Right triangle right there. We know this angle. And I'm going to claim we know this distance here. And we know that distance because it's going to be this number minus this number, because if you drop this straight down, imagine me dropping that straight down, that would run right into here, and you would get the difference between the two. So, Jordan, you got that for me? I need 1.636 minus 1.340. So that will give me this distance right here. 0.296. Okay, so green triangle goes like this. We know this angle. This is 0.296. Boys, can you guys be quiet? Turn off that music, please. Okay, so we got this, and the angle there is 68.3 degrees. Okay, and we got to find this distance right here. I'm just going to call this x. Why not? All right, so that's going to be, well, it looks like a tangent, right? We're using opposite and adjacent, so tangent of my angle, so tangent of 68.3 degrees equals x over 0.296. So work that out. That should give you, if I multiply both sides by 0.296, I get x equals, what does that end up equal? I have it written down here somewhere. 0.7438. Okay, which is this distance right here. So I know now how tall this is right there in green. That's good. Now, my second triangle, we're going to call this blue triangle. Blue triangle is going to be kind of different looking. It's going to go like this. It's going to come out. It's going to be a right angle, and it's going to come back in just like this. So I want to make a right angle right here. So I'm forcing myself a right angle right here, and that's my blue triangle. And in this blue triangle, I know a couple things. Because I know this angle, and I know this is a 90 degree right here, that means that this is going to be the same as this, so, or it's going to be the counter of it. So it's going to be complementary of it. So if you think about it, all the way to here is 180. This part is 90. So this minus 90 minus 180 should give me this. So here we go. We're going to go 180 degrees, which is the whole way around, minus 90, that's this chunk right here in the middle, minus this 68.3, and that's going to give me my angle that is here. That is right. Do a different color. That is right here. That'll be this angle. So that'll be, when you work that all out, I get 21.7 degrees. Okay, good. So if you think about my triangle here, do I know any of these distances? Ultimately, I want this distance in red right there. That's the y value that I want. Now, I'm going to claim that I can find this height now. I'm going to claim that I can find this height. And how I'm going to find that height is going to be a combination of a couple different things. So it's going to be this long distance, take away this guy, take away, let's see, long guy, take away that, take away this. And that should give me this distance in here, which is what I want. So let's see if we can figure that out. Okay, so yeah, imagine this line kind of scooched up a little bit. That would make maybe a little bit more sense. So it lines up there. Okay, all right, so if I go big guy, which is 1.715, take away the 0.488, take away this guy, which is 0.7438, and that's going to give me a result of 0.4832. Okay, So if you look at my blue triangle now I'm ready to roll with this thing. I got an angle, I got a side, and I'm ready to go. So my triangle kind of looks like this, where this angle right here we have solved to be 21.7, so 21.7. And this side length right here, this diagonal side length, is 0.4832. Now that's really good because what do I really want? I want this y value. And that y value is my answer. That's essentially all I need to do. So how do I find that y value? Well, that looks like it's going to be a sine to me because you got the opposite and the hypotenuse. So you got sine of your angle, sine of 21.7 equals opposite, which is y, over or hypotenuse, which is 0.4832. Clear that out, you got to multiply both sides by 0.4832, so 0.4832, 0.4832. Multiply both sides, these cancel, so your y value, which is your answer, which is what you want, should be 0.17866 is what I got, and that should be your answer right there, boys and girls. So there's another one, freebie. You just watched the video, you got another answer for free there. So yeah, that problem, really this line should be more, this blue line should have been more like this. That's kind of how I probably wanted to draw it. Not like that, but more like this. And that works out perfect. So there you go, there's another one.